Welcome to our lectures on fax devices. We shall continue today with the third lectures on the UPQC. That is, we have already discussed classifications and the reference generation technique. Now we shall concentrate on the rating. That is very important aspects because you know that actually power electronics devices rating increases heavily with the voltage and the current enhancement of the voltage and current. So for this reason, rating and control, these are the two important aspects of UPQC, and it required to be optimally require the rating for extract maximum benefit from the UPQC. So let us first talk about the control criteria. We have discussed about the reference generation technique for the DSTATCOM and the DVR, and same is extended to the UPQC. There may be the number of criteria for the control of the UPQC similar to the UPFC, that is Unified Power Flow Controller. It will be discussing the actually UPFC after UPQC in transmission system, which is mainly used to control the active power flow in both the direction and with injections of the series voltage and the active reactive powers. So this will be taken up in our subsequent classes, because I wanted to discuss of the UPQC first, because this is a power quality issues, and those who are approaching this is a fax devices basically, and it has played an important role for the power electronics engineers. And the UPFC that is connected into the transmission line is very versatile power controller used to control active and the reactive power, and it can operate in all the four quadrant of the VI characteristics. So that is actually the uniformity. Same way what you have seen the STATCOM and SVC. So here we can have all the coordinate of operation. We shall see to it how does it implemented. Similarly, UPQC also control and inject a series voltage between the AC mains and the consumer by the series DVR at any angle, that is also can operate 360-degree operation. Essentially, when you add the problem of the distributions and you act to operate fast, because you require to operate fast because of the fast changing harmonics, then you require, and device rating required to be reduced in the distribution transformer. So you can use fully controlled devices. Fully controlled devices when the transmission level is only GTO, but you can use IGBT in case of the UPQC, and thus you can take faster action with the help of the faster control device, and thus it is quite important to know that actually how fast and how accurate it can mitigate all the power quality issues. And power quality issues is a distribution problem, and nowadays actually we have this problem a lot, and thus UPQC has been featured, even though some people say the power quality should be taught as a separate subject, but it is integrated with the fax devices. So let us concentrate on the UPQC as UPQC-Q. So it will inject power inject voltage in quadrature. In this mode, the DVR is used for mainly reactive power injection for the fundamental voltage compensation. So in this case, the series voltage is injected in quadrature with the AC mains current or the current flowing through the DVR, so that no active power is needed for the series injection. So it will not take any active power, only to meet the losses of the switches it requires the active power. The DVR cannot compensate voltage swell in the UPQC Q mode, because it cannot inject the voltage in phase. Yes, it is in a perpendicular to it. So, sag or swell maintenance or the voltage regulation will not be actually possible, only it can actually control the flow of the reactive power. In this case, D-STATCOM compensate the reactive power of the consumer load and unity power factor is realized at point of common coupling. This is the principal operation of the Q UPQCQ. So, it can handle the reactive power very well, and it can basically inject voltage in quadrature in that, and also that D-STATCOM also can compensate the reactive power. Sag and swell compensation cannot be achieved, and moreover, if the current in D-STATCOM is apart from the reactive power, it may be an unbalanced kind of thing. So, then also it cannot compensate it. So, DVR inject, let us see that how does it work. DVR inject voltage in quadrature with the AC mains line. They in this case the voltage sag compensatable, there is also a limitation of the sag compensation depending upon the voltage rating of the DVR. Of course, these are the switches. So, switches has a voltage rating capability. So, voltage sags can be expressed in this format, that is, then let us assume that it is X, where X is not impedance, please do not mislead. So, VL minus VL square minus DVR by LC, where actually compensating voltage is this, where X represents the voltage sag for the compensation DVR is injected voltage by DVR, and LC is the load voltage after compensation. So, this is the voltage sag. Ultimately, you understand this is a load voltage VL, where you have to make Vs equal to VL with unity power factor, and this was basically your IL, and it will actually inject the DVR voltage in quadrature, and thus you will get this voltage. So, Vs become equal to VL and voltage is injected by it by quadrature. This is a simple principle of the operation of this UPQC Q type. In case of, if maximum in this case, if the maximum or the rated injected voltage of a DVR is known, then from this above equation, then amount of the sag it can compensate can be calculated. That is, it can calculate the maximum level of voltage sag that can be compensated by this mode of operation. So, it has a limited capability to correct the voltage sag, and in this case now the D-STATCOM has to supply some amount of the active power to meet the losses of the UPQC. So, it has to consume little bit of active power for switching and other losses. Since there is no one to supply real power, so it will come from actually it will come from the mains only. So, for this reason you require to maintain the DC bus voltage. So, what happens, let us see, but it does not supply the active power to the DVR, as DVR does not inject any active power. Therefore, in this mode UPQC is considered most conservative and provides the minimum level of compensation. You require to maintain the little bit of active power to maintain the capacitor voltage, and that is something by little change also you can do it, and you can optimally use the UPQC queue. The excuse me, the rating calculations for DVR and the STATCOM may be done from the phasor diagram. You see that this is a phasor. So, ultimately this is the amount of the injection you are doing, and what is the amount of this actually the reactive current you are feeding. From there you can calculate. The injected voltage of the DVR is essentially, it is under root of load voltage after compensation, that is VLC square minus VS square. Thus, the VA rating is of the DVR is DVR into IS, where IS is the source current, because it will see the total rating of it. So, Vs into IL cos phi into tan delta will come into the picture. So, let us go back and let us understand what is actually tan delta component of it. So, this is the angle VL prime, and this is basically the VLC. This angle is delta, this is angle between the VL prime or VLC with IS, and this component is essentially is the phi, that is uncompensated IL with Vs. So, now while compensation IS become IL, and definitely Vs become Vs prime. So, ultimately tan delta is essentially DVR by Vs. So, from this phasor we can see that, so ultimately you can write, we can substitute DVR in terms of the Vs. So, that is the system rating of it. So, Vs IL cos phi into tan delta. Since that is what it is written, Is and IL are supplied by the load current, load and the source current respectively, and cos phi is the load power factor, and delta is the angle between the load voltage and the voltage after compensation. So, that is what we have found, that voltage after compensation. So, from there actually you can calculate that what should be the rating of the DVR. So, DVR rating will definitely depend on the tan delta, and which is non-linear. So, now let us come to the current rating of the DSTATCOM. So, that is the IL, that is a inductive portion of it that required to be compensated. So, that is actually DSTATCOM current rating. Essentially it is basically the fraction of compensation, that is x, 1 minus x square plus cos square phi minus 2 cos phi cos minus sigma into minus x by 1, where actually this has to be changed by delta. Actually this is the equation that has to be governed. So, if this term actually depend on the amount of the compensation you are doing x, and of course the difference between phi and delta. So, assuming that actually the VA rating of the actually is basically IS dt equal to voltage, load voltage after compensation into I DST. So, therefore, the total rating of the UPQC will be the sum up of these two rating, that is IDST, that is DSTATCOM rating, and the DVR rating. So, total will have a same rating. So, remember that actually while talking about few topologies, I was discussing the normal topology is the 12 switch, for the 2-level inverter, and we have our reduced switch topologies. So, ultimately when you are reducing the switches, then what happen, actually the stress across the switches will be increasing, because this is the sum of these two rating. Ultimately some switch, if it is actually providing both series as well as shunt compensation, then rating of the switch required to be higher. For the control of the DSTATCOM, the part of the UPQC, DSTATCOM part of the UPQC, the sensing of the PCC voltage, these are the requirements, these are the sensor you require. Sensing of the PCC voltage, load current, supply current, and the DC voltage is required to drive, to actually find it out the reference of supply current for the PWM control according to the SRF or instantaneous reactive power theory or whatever may be, mostly in the time domain. The number of sensors is almost same for different kind of controller. Only Smedley and et al. Actually proposed a PLL less control, the number of sensors there actually get reduced, but there is a own limitations. The supply current have to supply only the active power, so that actually it will always see that as if the resistive load is connected to it, irrespective of the pattern of the load, which has two parts. One has load active power and another to meet the losses of the UPQC. These are the two parts you have to fit. Losses of the UPQC has to have a real power. The active power component of the load current is estimated by SRF transformation to the load current, and then filtered its DC component. We shall see the block diagram of it, which represents the required active power component of the load current. We are describing it, thereafter we shall show that how does it actually done by a block diagram. The SRF transformation, the transformation angle is obtained from the PLL, phase lock loop, over the positive sequence of the PCC voltages. Other part of the active power component of the supply current is estimated by using a PI controller or PID controller over the DC bus voltage of the UPQC. So, after describing, I will explain the block diagram of it. Sum of this active power component of supply current is considered as the amplitude of the reference supply current. This amplitude of the reference supply current and the transformation angle obtained from the PLL over the positive sequence PCC supply voltage are used to compute 3-phase instantaneous reference supply current. So, in that way you can compute the 3-phase reference supply current with the SRF. So, this 3-phase reference supply current is sensed. Supply currents are used in the PWM supply current used in the PWM current control for the generations of the gating signals of IGBT of the DSTATCOM. This is the actually DVR, this is a DSTATCOM part of the control by SRF technique. Now, let us come to this DVR part of the UPQC. The control of this DVR, the reference injected voltage R computed from the difference of the reference load voltage and the sensed PCC voltage. This is required to be compared. The 3-phase reference load voltage R computed from a desired reference amplitude of the load voltage and the transformations angle are obtained from the PLL over the sensed devious or power supplies. These 3-phase reference injected voltage are given to the PWM voltage controller for the generating the gating signal of the IGBT or DVR. Now, let us come to the next topic, that is the control of the UPQC P, that is in phase. It will inject the voltage in phase. So, ultimately this is the DVR voltage that will apply the voltage in phase or in 180 degree minus phase. So, it is a effective sag or the soil compensator, and it does not have any power to compensate the reactive power. Essentially, it is a sag and soil compensator. We shall discuss all the control technique, thereafter we shall actually discuss this actually the block diagram of UPQC. This control algorithm of UPQC has been conceptualized for minimum voltage injection by DVR. As it is evident from the phasor that the DVR inject the minimum voltages for both condition, voltage sag as well as the voltage soil, but most of the problems are associated with the sag. So, it is sometime it is said to be the sag compensator. In this mode, DVR needs the totally the active power voltage injected in series compensation. So, it will take the active power from the source and boost up the voltage or suck the power from the source to reduce the swell. In case of the series voltage injected in phase with the AC mains or PCC voltages, thus requiring only the active power that has to be fed or received by the D STATCOM through the DC bus. So, this is the principle of operation of UPQC P. To increase, and what happens then, it increases the current and thus the KVA rating of the D STATCOM. However, KVA rating of the DVR is minimal in this operation mode of UPQC as UPQC P, because it is only sees the in phase component of the voltage. And in this case also the D STATCOM compensate the active reactive power of the consumer load current, and all the current and all the current related problem with the harmonics. So, voltage sags here also can be expressed, this is x equal to VL minus Vs by VL. So, you can cancel it. So, ultimately you get, since they are in phase component, dVr by LC, very simple way to compute from the phasor. Therefore, the voltage rating of the compensator may be achieved from the required minimum value of the sag as well as the swell compensation. The UPQC P mode of operation requires minimum injection voltage and thus minimum VA rating of the DVR, but at expense of the D STATCOM rating. And what happened, which increases due to the large active power flow through the D STATCOM, because if you have a UPQC, and I assume that is a right shunt compensation, so real power will flow through the D STATCOM and that will be injected by this DVR. This is the way of real power flow. Thus, rating of the D STATCOM is going to be increased. Therefore, this type of UPQC does not have minimum overall VA rating consisting of both element of the UPQC. And rating calculation of the DVR and the STATCOM can be, DVR rating will be VLC minus VS, that is LC into X. You have to design for how much sag occurs into that particular place, 40% sag, 30% sag or something like that, or same way the swell. So, generally you have a over voltage and the under voltage delays. So, accordingly you have to take care of and you calculate the value of X. So, the VA rating of the DVR is a totally an active power and is expressed as SDVR equal to V DVR into IS. From there LC IL cos phi will come, and from there IS and IL are the supply load current respectively, and phi is the load power factor. Here delta will not come, and current rating of the D STATCOM will be given by IL minus IS square plus fraction of this sag compensator, that is XIL cos phi square. From there actually VA rating of the D STATCOM is VLC into LC by dt. So, it is a multiplication of this. Similarly, therefore, the rating will be same DVR plus D STATCOM, but generally D STATCOM will actually will have a more rating than the DVR. So, what we can conclude, for the real time time control and implementation of this mode, UPQC is also straightforward, similar to the D STATCOM, control into the UPQC Q mode of operation. For this control, DVR actually reference is DVR reference injected voltage are computed from the reference of the reference load voltage and the sense PCC voltage, and it can only correct the sag, mind it. The 3 phase reference load voltage are computed from the desired or the reference amplitude of the load voltage, and transformation angle is obtained from the PLL over the sense PCC, as this phase difference and the load voltage are fed into the point of common coupling. This 3 phase reference is injected voltage gives you the actually the PWM required to generate the reference for the voltage source converter. This is a way of operation of UPQC P. So, we shall continue with our next class with the control and the rating of the UPQC S. Thank you for your kind attention.